All right, this is the last example of chapter 3, Gauss law. It is question 46. Let's read the question first. Question 46. A 10 centimeter by 10 centimeter piece of aluminum foil of 0.1 millimeter thickness has a charge of 20 microcoulomb that's spread on both wide side surface evenly. You may ignore the charge on the thin side of the edge. Part A, find the charge density, the surface charge density. Part B, find the electric field 1 centimeter from the center, assuming approximate planar symmetry. One important point for part B is that we are far away from inside the thin plane. All right. Now we're going to draw our thin plane over here. Again, to solve that problem, we'll need to draw a Gaussian box. But before we do any of this, let's solve part A, which we need to find the surface charge density. And there's a catch in the question. We are told the total charge of that object. And we are also told the area of one side of the sheet. Now what happened is, basically, since the charge spread on both surface, well, the surface is really the two sides of the sheet. So one side of the sheet, and I name the area of one side A1 and A2. So A1 and A2, that has to be the same by the way, is equal to 10 centimeter multiplied by 10 centimeter. It has an area of 10 centimeter per multiplied by 10 centimeter, or 0.1 square. So it has an area of 0.01 meter square. Now, obviously, the true area is twice that amount because this is the area on each side of the sheet. All right? To find the surface charge density, we take the total charge divided by the total area. And again, we have to multiply that term by 2. We get a surface charge density of 1 millicoulomb per meter square. All right. In part B, we need to draw our Gaussian surface, and again, we need to draw a box for planar symmetry. We will need to consider the area on both sides, and again, this is what's unique about planar symmetry, is we start our flux is equal to 2EA. That's the only difference compared to the other two methods, and you can see that really it's because we're using the area of only one side of the box here. All right, so 2EA is equal to the charge divided by epsilon 0. The charge over here has to be sigma, or the surface charge density, multiplied by the area. We have area on the top part and bottom part, they cancel out. The electric field is equal, as expected, to the surface charge density divided by 2 epsilon 0. If we input all the value, we get 5.65 multiplied by 10 to the power 7 Newton per coulomb. So as you can see, the problem involving planar symmetry are not too complex. It's just about remembering that the flux, there's a 2 over here. That's the only difference. All right, so we are done with Gauss law. Just a note, you can be sure there will be a question on Gauss law on the first test. That's for sure. So make sure you practice all these concepts. Spherical, cylindrical, and planar symmetry. They are important. All right, so see you in the next chapter.